So page 57 is unit 7 objectives, and page 58 is rational exponents. So page 57, unit 7 objectives, page 58, rational exponents. Flip on over to page 57 for our objectives for the day. So page 57, unit 7 objectives. And today we're going to talk about simplifying expressions that contain rational exponents. So simplifying expressions containing rational exponents. This will be what was problem like 1 through 6 on what you've just worked on today. So unit 7 objectives, simplifying expressions containing rational exponents. Once we've got that written down, flip on over to 58. And at the top of the page, put rational exponents, page 58. So the first thing we're going to talk about today is something called an index. So an index is going to be defined as the small number to the left of the radical symbol that tells you which route to take. So an index is a small number to the left of the radical that tells us which route to take. So the normal thing we look at when we think about roots is what? Bless you. Bless you. Square roots. The square root symbol is that right there. Let's just say we're taking the square root of 16. So an index is going to be a number that's placed right here. We have an imaginary number that's placed right here. What do you think it might be? 2. So out here, the 2 is our index. This is our radical sign. And 16 is our radicand, the number inside the radical sign. So we all know the square root of 16 to be 4. That's 2. That's the... Sorry, this is just the radical sign. That's a square, sorry. I can see how you saw that. So we take the square root of 16, that equals 4. In general, the index is x, and then we take the root of the radicand x of y. So x is the index, y is the radicand, and that's just in general conceptual view of the index, radicand, and radical sign. So today, we're going to talk about another way to write the square root of 16. And the way we're going to do that is talk about something like this. So a number raised to the power of 1 over n is equal to the nth root of that number. So who can tell me what that might be saying right there? How would that look visually? No? So you said x to the 1 over n is equal to what? Very good. So the denominator, what could the denominator be also classified as? What's that new word we just learned? Index. So when you have a number raised to a fraction, the denominator will be the index of the radical. The base is going to be what? The radicand. And then we have our square root sign. So let's say we had 4 to the 1/2 power. How would we rewrite this with the radical symbol? So what's our 2 stand for? Stands for our index. And what's our 4? Radicand. Good. So this is how we can translate from 4 to the 1/2 to the square root of 4. So these two things right here, these two expressions are equivalent. 4 to the 1/2 is the same thing as saying the square root of 4. How this works is we're going to show an algebraic proof of how this works. So let's say we have the square root of y is equivalent to b to the x. So let's say these two things are equal. What's the inverse operation of a square root? What do you do to get rid of square roots? You square it. So we're going to go ahead and square both sides. So what happens when you square a square root? What is left? In this case, y. So we're going to recall some information that we learned in pre-algebra and we reviewed at the start of the semester. When powers have powers, so let's say you had x squared squared. What do we do with those powers? What do we do with the 2 and the 2? We multiply them. Good. Giving us x to the 4th. So here we have b to the x squared. So what is that going to leave us with? B to the 2x. And that's because of the power of power property. So we have this imaginary 1 up here. Sorry, change this b to a y. I messed up. Sorry about that. So now we have y to the first equals y to the 2k, or 2x. So since y, the bases are the same, what can we say about their exponents? What must be true since y to the first equals y to the 2x? That they're the same, so that means what, Noah? So 1 has to equal 2x, right? Which means x equals x equals 1/2. And up here we had y to the x, right? So originally we had the square root of y is equal to y x. And now we just found that x equals 1/2. Thus saying the square root of y is equivalent to y to the 1/2. So that is the algebraic proof of how you change a square root to a base to the 1/2 power. Do we all see how that works? Do we all see that the square root of y is the same thing as writing y to the 1/2? We good? So let's take a look at a couple examples of just changing the written portion. So let's say we have the square root of 64. What's another way to rewrite the square root of 64? Other than 8. Jacob, what was that? 64 to the 1/2 power. So we have 64 to the 1/2 power. So the square root of 64 is the same thing as 64 to the 1/2 power. Let's try another example. Let's say we had 25 to the 1/2 power. What does that equal to? Square root. Good, Miles. We have the square root of 25. Let's say we had 49 to the 1/2. What is that also written as? Square root of 49. Good. And one more. Let's just say you have 100. The square root of 100. What's another way to write that? 100 raised to the 1/2 power. So are we seeing that there are two ways now to write the square root of a number? Fixing that. So now let's say we had the cubed root of something. Let's say we had the cubed root of x. Similar idea. Now we're taking the cubed root. How could we rewrite the cubed root of x? X to the 1/3 power. So this works with all roots, the transformation of it. X to the 1/3 power is the same thing as x, the cubed root of x. So let's look at an example. Maybe we have the cubed root of 8. Does anybody know what the cubed root of 8 might be? 2. How'd you get there, Noah? 2 times 2 is 4. Times 4 is 8, or 2 times 4 times. Yeah, 2 times 2 is 4. 2 times 4 is 8. So the cube root of 8 is 2. But what's another way that we can rewrite the cube root of 8? Eight to the 1/3 power. So whenever you see the index of a radical and a radicand, what do you need to take? What's the first thing you need to do? So what's the index become? The index becomes denominator. So one rule we need to remember is the index becomes the denominator yes, Jacob, of the exponent. Good. Becomes the denominator of the exponent. So the index becomes the denominator of the exponent. What is the base or the radicand? What's the relationship between the base and the radicand? The radicand becomes the base and vice versa. So the other thing we need to know is the radicand becomes the base and both of these work in either direction. So the exponent, the denominator of the exponent becomes the index and the base becomes the radicand. So here's one last quick thought, little challenge question that we might think of. So say we had 64 raised to the 2/3 power. What do we think that might look like? So going back to our rules, what's our base? 64. So the radicand and the base are the same thing, right? So we can write a square root symbol and make the base our radicand. So we have 64. What's the denominator now become? The index. So what do we think we need to do with that 2? Put it after the 64, and what is it representing? It's the exponent. Derek, good. So it's now the exponent. You're going to see a couple problems like this on your homework. So what do you need to do with the base? What does that become? The radicand. What does the denominator of the exponent become? The index. And this third thing that we just learned is the numerator becomes what? The new exponent. All this works both ways. You're going to change on your homework, you're going to change it from base to an exponent to a radicand, or to a radical, or from radical to a base with an exponent. So your homework is on Google Classroom. It's problems 1 through 9. All you have to do is change the signs, the way it works. You can solve it with your calculator if you like, but I want to see on your homework, I need to see you changing from one form to the other. I don't want to just see the answer after you plugged it into your calculator. I want to see how you changed it.